And here's one from the beginning of the semester. Use the definition of the derivative, that means limits, to prove that if you have the function the square root of x, that the derivative is equal to 1 over 2 times the square root of x. So I'm going to use the definition that says the limit as x approaches a of f of x minus f of a over x minus a. So this is going to be the square root of x. This will be the square root of a. So the limit x approaches a, then it's the square root of x minus the square root of a over x minus a. And now we need to do some algebra to simplify, and the goal is to get this x minus a to cancel, and then we can go ahead and substitute that x becomes an a. So in order to do that, use the conjugate, which will be the square root of x plus the square root of a. Multiply on the top by that, and multiply the bottom by that. So for the numerator, when you're multiplying a conjugate, it's actually less work than usual. You multiply the first two, the square root of x times the square root of x, that's just going to be x. And the middle terms, this square root of x and a positive square root of a, and square root of x and negative square root of a will cancel. So then we just need the last one times the last one, and that would be a negative times positive, so it's negative a. And for the denominator, you can just leave it in parentheses. X minus a gets multiplied with the square root of x plus the square root of a. And then the good news, x minus a and x minus a cancel, leaving just a 1 on top. And then I can go ahead and substitute that x becomes an a right here. So then it's going to be a 1, and the denominator has the square root of a plus another square root of a, which means the denominator has 2 of them that are the square root of a. And you could literally be finished right there. Or you could say, well, if x became an a, then I could also write this as 1 over 2 times the square root of x, and then it's finished.